Okay, in 1.2, we're going to introduce the concept of limits and a little bit notation as well. Okay, so for all three of these graphs, as x approaches 2, f of x approaches 1. And this is how we'll say it. It's saying as x approaches 2, when it says f of x, it's talking about the y value. The y value is approaching 1. It's not saying that at x equals 2, y equals to 1. It's saying it's approaching 1, and it's gonna be distinguishing the difference between the two. So if we look at this first graph, this is the notation we use. It says the limit as x approaches 2 of f of x equals. So I'm going to go ahead and look at the graph. X is 2 is this point, is at this point right here. If I approach that point from the left side, it looks like the y value is going to 1. If I travel along the graph in the other direction, it also looks like the y value is going to 1, which is why the limit as x approaches 2 of f of x is 1, because from both directions, the y value is approaching 1 as I approach x approaches 2. Now, f of 2 is saying at x equals 2, what is the actual y value? So at x equals 2, the actual y value is actually 1. So in this case, the limit as x approaches 2 of f of x is the same as f of 2. They have the same y value. Okay, on the next graph, they're not going to match. I already know the answer, but let's look at it to see why. Okay, so x is 2 is at this point on the graph. As I approach from the left, it appears like the y value is approaching 1. As I approach from the right, it also looks like the y value is approaching 1. So because the x, as we approach, x approaches 2 from both sides, the y value is approaching 1. The limit as x approaches 2 of f of x equals to 1. Now, at x equals 2, what is the actual y value? Well, at x equals 2, there's an open circle. There's no value here at all. So in this case, f of 2 does not exist. There's no value there at all. Okay, let's look at the next graph. As x approaches 2 on this graph, if I come from the left side and if I come from the right side, it appears that the y value is approaching 1. Okay, now at f of 2 is at x equals 2, what is the actual y value at the point plotted there, if there is one? So at x equals 2, the actual point plotted is way up here. So f of 2 is actually 3. So limit as x approaches 2 of f of x is 1, however, f of 2 is 3. So they don't have to match. Okay, so for the first example, we're just going to look at the graph and identify the values, switching back and forth between limits and actually evaluating the function at a certain x value. Okay, this is my graph of f of x. Okay, so limit as x approaches 1. Okay, where is x is 1? X is 1 is right here. Okay, if I approach 1 from this way and from this way, it looks like the y value is approaching -1. Okay, the next one says, for number 2, it says f of -3. So at x equals -3, I want to know what the actual y value of the point plotted there is. So -3 is right here. The actual point is right here. So this is -3 comma 0. So f of -3 is 0. Okay, now let's look as x approaches 2. Okay, x approaches 2. 2 is way up here. Okay, if I come from the left side of the graph, it's going to here. If I come in the right direction, it looks here. Both ways, it looks like the y value is approaching 2. Okay, now what is f of 2 actually? So at x equals 2, the point plotted there is actually way up here. So f of 2 is 3 because the point 2 comma 3 is actually plotted on the graph. Okay, f of 1 at x equals 1. There's no value here. There's no point plotted at anywhere there. So f of 1 does not exist, or it has no value, or something to show that there is no point plotted there. Okay, f of -2. -2 is over here. The point plotted is right here, so that's -2 comma 2, which means f of -2 is 2. As x approaches 0, let's see, the y value is going towards -2 in both directions. And as x approaches -3, Looks like the y is approaching 1 and the y is also approaching 1 in the other direction. And you do need to check both directions even though it doesn't tell you to do so. Okay, now example 2, it says give an interpretation of the statement this thing. That they just want you to translate the limit notation into English words. Okay, so what is this saying? It says LAM x arrow 7. So the limit as x approaches 7 of f of x is 10. Okay, and then one last side note. It says a limit does not tell us the value of f of x. Sometimes it matches the value of f of x, but it does not always match the value of f of x. So let me sketch a quick graph. Let's see, let's make this 1. Let's do the same thing here. Okay, so if I draw a random function going through here, okay, in this case, the limit as x approaches 1 from this direction, and this direction goes to some y value, I don't know what it is, and there is also a point here, which means the limit as x approaches 1 of f of x is actually the same of f of 1, because there is a y value there, there's a point plotted, it's a continuous function. If I make a graph that's very similar but not, let's see, say it's approaching, but there's not actually a value there. Okay, in this case, the limit as x approaches 1 exists, it's whatever the y value is approaching right here. However, f of 1 does not exist because it's not there. I could make it exist, maybe I put it up here, but now this point is not matching the limit as x approaches 1.